In this problem, we are given the root of a binary search tree and the value, or key. Our objective is to delete the node with the given key from the BST and ensure the tree's properties remain intact after the deletion. We must locate the node that needs to be removed and adjust the tree structure accordingly. The structure of a binary tree node is defined by the tree node struct. Each node includes an integer value, val, and pointers to its left and right children. This definition is crucial for representing nodes in our BST. The tree node struct ensures that each node is properly linked to its children, allowing us to navigate the tree efficiently. The delete node function accepts the root of the binary tree and the value of the node to be deleted as parameters. It returns the root of the tree after the specified node has been deleted. By doing so, we ensure that the tree remains a valid BST after the deletion operation. The delete node function uses a recursive approach to search for the node with a specified value and adjust the tree to maintain its BST properties after deletion. Initially, the function checks if the tree is empty. If root is null, the function returns null, indicating there is nothing to delete. This base case handles the scenario where the tree is empty or we have reached a leaf node without finding the key. If the value of the current node is greater than the key, the function continues the search in the left subtree by recursively calling delete node on left pointed to by root. This is because in a BST, all values in the left subtree are less than the value of the root node. Conversely, if the value of the current node is less than the key, the function proceeds to the right subtree by calling delete node on right pointed to by root. This is because all values in the right subtree are greater than the value of the root node. When the node to be deleted is found, several scenarios are considered. If the node has no left child, the function returns the right child of the node. Similarly, if the node has no right child, the function returns the left child of the node. These cases handle the scenarios where the node to be deleted has only one child or no children at all, making the deletion straightforward. If the node to be deleted has both left and right children, we need to find its successor. The successor is the smallest node in the right subtree, which is the node with the lowest value greater than the value of the node to be deleted. We locate the successor by traversing to the leftmost node of the right subtree. This ensures that we find the smallest value in the right subtree, maintaining the BST properties. Once the successor is found, we replace the value of the node to be deleted with the successor's value and then recursively delete the successor's node from the right subtree. This ensures that the BST properties are maintained. The replacement and deletion of the successor ensure that we do not violate the binary search tree properties while removing the node with the two children. The delete node function continues this recursive process until it locates and deletes the node with a specified value. The recursion provides an efficient and elegant way to handle node deletion in a BST. This recursive approach simplifies the implementation and ensures that all edge cases are handled gracefully. Testing the code thoroughly is essential to ensure its correctness and performance. We encourage you to test your implementations with various cases, including edge cases such as deleting leaf nodes, nodes with one child, and nodes with two children.